All right, the last thing I wanted to talk about for our Monday asynchronous part is molecule structure and shape. And I apologize for forgetting to add this in the original one, but maybe it's a good thing to split these up a little bit anyway, but this will be short. So molecules have shape. When you see this water molecule here, here's our covalent bond. These are the shared pairs between oxygen and each of these hydrogens. Two hydrogens, the one oxygen. They're always drawn in this form, where the hydrogens kind of are at an angle. And there's a reason for that. It's because water has a very distinctive shape. So where these hydrogens are in relation to the water in relation to, or the oxygen in relation to each other is very important and very distinct. So how do they come by these shapes? All right, so let's think about carbon for a second. Carbon has a valence of 4, so will bind with 4 hydrogens. In doing so, it ends up with 4 shared pairs. Now remember, electrons are negatively charged. Therefore, those electrons, those shared pairs of electrons, they're going to stay as far away from each other as possible. And in order to do that, if we jump over here for a second, you have to think in 3 dimensions. All right, so this is the carbon in the middle. We have these 2 inner shell electrons, and these are the shared pairs between the hydrogens. Each hydrogen is blue. So there's 4 hydrogens, and this is the carbon in the middle. But those shared pairs want to stay as far apart from each other as they can. And in 3 dimensions, that means that they are going to be at these angles that we see here. Because it's not going to be a square, because we have, if I kind of pulled this up to the camera, this is the carbon, these are the 4 hydrogens. So make sure you're looking kind of at me in the camera at this point. This keeps all of these at the farthest angle apart from each other as possible. Okay? So it's very important to understand that, because that relates to what happens with the shape of these. So carbon is a very symmetrical molecule. Right? Those hydrogens are kept as far away from each other as possible. The hydrogens, when they bind to nitrogen, are kept as far away as possible as well. So why don't they just go out in this plane? Why do we still kind of have them angled down like this? Why are they angled like a pyramid? Right? Well, let's think about that for a second. So remember our valences. We'll come back to that in a second. I've tried to draw this out. I apologize that it looks pretty weird, but the red are the electrons from carbon, the blue are the electrons from hydrogen, and they are shared here, and they are kept as far apart from each other as possible. All right? That's this molecule here looking in the camera. Now remember, nitrogen already has 5 electrons in its outer shell. It only needs 3 more. So it already has 2 that are paired even before it starts bonding, and then it needs 3 more, so it binds to 3 hydrogens to collect those 3 extras by sharing. These are covalent bonds. So this pair of electrons up here acts just like this hydrogen did. It needs to stay as far away from all these electrons as it can, just as if there was a bond up here. So in reality, this nitrogen with its 3 hydrogens is acting the same shape as carbon with its 4 hydrogens. You just have to think of this pair of electrons as another hydrogen. But since it's already paired, it doesn't need a bond there. So these electrons are as far apart from that shared pair, and that shared pair, and that shared pair. And so that brings us to oxygen, whose valence is only 2, right? Well, if we think about it, if we took this carbon molecule, all right, I know the video is small of me, but if we took this carbon molecule and we made it oxygen where 2 of these are already pairs, those 2 hydrogens end up with this angle apart, just like this. So there would be a shared pair of electrons kind of sticking up here and up there. And so these hydrogens are just like these 2 if you got rid of the other 2. And that keeps them in an angle because we have the other shared electrons at the top here. So it's almost impossible to draw them appropriately in 2 dimensions because remember we would also have things sticking in and out. But basically this is what those previously shared pairs of electrons that oxygen already had, because it had 6, 1, 2, 3, 4, 5, and 6 of the pair that it contributed. Those unshared pairs that were already pairs still stick here and keep these at that angle. And this is really important because this is going to allow oxygen to have a dipole on one side, a negative dipole on the side that kind of has oxygen sticking out, and a positive dipole on the side that has the hydrogens sticking out in that angled molecule that you can see kind of on the screen, the video of me now. All right, so keep those shapes in mind as we move forward, and we'll talk about electronegativity on Wednesday.